And so one reason why we use that tangent slope and we do that definition, the limit as h approaches 0 of f of a plus h minus f of a, divide that by h, is because we want to be able to figure out what's happening at specific points, specific time intervals. A lot of calculus is going to be more real life situations where we want instantaneous pieces of information. We don't want to have time to lapse between it. We want it right now. So at that specific point in time, what was happening? I don't want to figure out what's happening between these two specific times. The time might be too different. All right. So when it's asking us for an instantaneous rate of change, it is asking us for a slope. It's asking us for the speed of an object at one specific time. So really, when it asks us for that, it wants slope. It wants slope at one piece of information, slope at a specific point, right? So we're going to go and I'm going to show you how we can actually do that and accomplish this, right? First off, I need a function. So I'm going to say my function, f of t is equal to 16t squared. What I want to do is I want to find the speed of this object, whatever the object is, when the time is equal to 1 second, right? So now I've got this time interval. I know that it's at this specific point. Well, I want to be able to find the slope. Well, normally, if I want to find slope, I need 2 points. Well, I don't have 2 points. I only have one specific piece of information. So if I want to find an instantaneous rate of change, an instant slope at 1 point, I need to be able to find a limit. Well, in order to be able to find a limit, once again, we got to go through that definition, that f of a plus h minus f of a all over h, as that limit approaches 0. All right? So that's what we're going to start to look through. And this is what I'm writing down. What this question is asking us, it's asking us for slope at a specific time, rate of change at 1 point. Right? So we need to be able to understand that. We need to be able to go through these and say, okay, when it asks us for instantaneous rate of change, what does this actually mean? What is it telling me to do? All right. Well, I know what rate of change means. It means slope. How do I find an instant slope, an instant rate of change? Well, in order to do that, I got to go back to all this information that we're going through. I need to be able to find that limit. All right. So that's what I'm writing down here. To do this, we need to use that definition, the limit as h approaches 0 of f of a plus h minus f of a all over h. So on the next page of information, that's what I'm going to show you. I want to show you how you actually go through this. All right. Now, my original function was f of t is equal to 16t squared. What I need to do next, and I need to be able to find that t plus h. So I got to find that second point. Remember, I don't want that distance between these 2 points to be astronomically large. I want it to be so minuscule it's 0, basically 0, but it can't be. Remember, I can't find slope when there aren't 2 points. I do need 2 specific points. So I'm going to add a little distance to that first point. If my first point, my first x value is t, I'm going to add a distance to it. I'm going to go t plus h, which means that changes my output. So if you look at my original one, f of t is equal to 16t squared. Any input value says, take your input value, t, square it, multiply it by 16. Well, now look at my input. My input changed to t plus h. So I'm going to do the exact same thing, same operations. I'm going to take that new input, I'm going to square it, I'm going to multiply it by 16. So you can see I took my t plus h, I squared it, I multiplied it by 16. Now the next part is a lot of algebra. Right? I'm going to take t plus h, I'm going to multiply it out. I'm going to take that 16, I'm going to distribute it into that parenthesis. So this is all our algebra stuff. This is where we need to be spot on with all of this. So you can see I squared out the t plus h. Now I distributed the 16 through. Now I actually have all the information I need in order to be able to find this limit. So we're going to write down here the limit as h approaches 0 of f of t plus h minus f of t, in this case, all over h. So, I changed it from f of a plus h because my function changed. It's going to change. You need to be able to change with it as well. You just need to be able to understand. It's the same thing. It's the same concept. Different variables, big deal. The same thing. So what is f of t plus h equal to? Well, that's my 16t squared plus 32th plus 16h squared. So I'm going to write that. That's my 16t squared plus 32th plus 16h squared. What is, I'm going to subtract f of t. Well, what is f of t? That's my 16t squared. It's the change in your y values. My new y value is that long piece that I just wrote. My first y value was 16t squared. I'm going to divide that by h. Remember, I could have done t plus h minus t, but it's t minus t. You're always left with h. H is always going to be in your denominator. Right? Now, I'm going to start to simplify some stuff. You can see that the 16t squareds are going to cancel each other out. Now my limit, as h approaches 0, what I'm left with is 32th plus 16h squared all over h. I can simplify even further. This is algebra. We just distributed, we multiplied, we combined like terms. I'm going to simplify by dividing. So taking h out of every piece of information. My limit as h approaches 0 is now 32t plus 16h. Now this is where calculus comes into play. Everything up to this point, algebra. Algebra, algebra, algebra. Distribute. Combine like terms. Simplify. Now, if you look at this piece, this limit that I just wrote, it says h is going to approach 0. So right now it says 32 times t, whatever that is, plus 16 times your h value. H is approaching 0. That is going to be smaller and smaller. That is an insignificant number. It means nothing. As h goes 0, get rid of it. It means nothing. You're actually left with 32t. That is your limit. That we just evaluated. Now that 32t represents how we are going to find speed at any specific point, at any one time. So if I wanted the speed at time equals 3 seconds or 4 seconds or 2.2 seconds, I just take 32 and multiply it by my time. Right? So in this case, we wanted it when time was equal to 1. So when t equals 1, my speed is going to be 32, and I'm just going to say feet per second. We didn't have any kind of major units. Make sure that you use the proper units when you're going through these types of problems.